B3. A1. So what's latent heat, Ibrahim? Yeah. So in this case, vaporization. What state is that? Is the energy to change the state of a mass from liquid to gas? And everybody, including the September students, forgot to say and not a change in temperature. So nearly everybody, I think in fact everybody forgot to say that. So it's 2 marks, most people only got 1 mark. Okay. Sketch a graph showing the temperature against time of ice being melted. Okay. Can I scroll down? Yeah. So here we have this is the temperature in Celsius and this is the time in seconds, and then let's say here is -5. It's not really to scale, I know, and here's 105. So what's going to happen here is it starts at -5, then slowly gets warmer and warmer until it reaches 0, then it stays at 0 for a while, and then it starts to increase until it gets up to 100 here. Then it stays at 100 for a while, and then it increases again. So this blue piece here, this is when it's ice. And then this green piece here, what's happening? Yeah, it's changing. So that's like when it's melting. And then this red piece here, this is when it's a liquid. Yeah. And then this piece here, this is when it's boiling off. So this is when it's changing from a liquid to a gas, yeah. And here's a gas. So actually, this here is I'll put it as a solid rather than ice. So this one here is a solid. So this is ice, water, steam. And then I'm putting in loads of information, more than I need, and then these bits here are transition. When it's changing. Now it's only 3 marks, so I put in much more than I need to, so I'll definitely get the 3 marks here. Okay, can I go to the next part? Yep. So part 3 is a calculation. They say, determine the quantity of heat required to raise the temperature of ice from that and turn it into steam at that. So what's happening here is you have your ice at -5 Celsius and it's 0.25 kilograms. And then what you have to do is change your ice into ice at 0 Celsius, 0.25 kilograms. This is still ice. Then you need to change your ice into water at 0 Celsius, 0.25 kilograms. Running out of space now. Then what you have to do is change your water into boiling water at 100 Celsius, still 0.25 kilograms. And then finally, you have to change this water into steam of 100 Celsius and 0.25 kilograms. So in fact, this problem can be broken up into 1, 2, 3, 4 calculations. So calculation number 1. The energy here, I'll call it Q1. Which formula do I need? Do I need MC delta T or do I need ML? Yeah, I need MC delta T. And for number 2, Q2, what do I need, Ibrahim? Yeah? Yep. And then for number 3, yeah, MC delta T. And then finally number 4, ML. Now in the first case the M is 0.25, the C for ice is given, heat capacity of ice is 2.1 times 10 to the 3, and then what's the delta T, the change in the temperature? 5. Then for the second one the M is 0.25 and the latent heat of fusion is 3.34 times 10 to the 5, and then here it's 0.25, the latent heat of water is 4.18, 10 to the 3, and then the temperature change is 100, and then finally 0.25, and then vaporization is 2.26, 10 to the 6. So then the total energy would be the addition of all of those. So, calculator time, 2.1, 10.3. So when you add up all of those numbers, you get 7.54875 joules. Or if you want, that's 755 kilojoules, if you prefer. Yeah, whichever you like. It's just a long calculation, that's all it is. You have to add all of those numbers together, that's all. Okay, can I do B part? So what's Boyle's law? Who remembers? It is the law that says when T is constant, the pressure is inversely proportional to the volume. So in other words, Boyle said if you half the volume, you double the pressure. Or if you double the volume, you half the pressure. It's opposite relationship. So, for example, he said if the volume gets doubled, then that means the pressure will reduce by half. Or if the volume gets halved, then the pressure will double. It's basically Boyle's law. It's important as well that the temperature is kept constant. All the September students forgot this. I don't know if they just forgot his name. I don't know. Anyways, it's only 2 marks, so it's not so big. Oh, this is okay. When temperature is constant, pressure will be proportional to volume, but of course you should also say this is for gas, of course, not a solid or liquid. Now you should like the second part. It should remind you of chemistry. Part 2 here. You have 0.575 kilograms of oxygen. Is oxygen one of the 7 diatomics? It is, isn't it? And the pressure is 1.51 times 10 to the 5 pascals, and the temperature is 283 Kelvin. Yeah? And the molar mass, or molecular mass, is 32. Or if you want to be a bit more clear, it's saying that 32 grams per mole. 1 mole is 32 grams. Yeah, 32 grams per mole. Okay, what is the volume? Well, that's just PV equals nRT. So V equals nRT over P. Now, do we know the N? No, we have to work out the N actually, so we'll do that first. Okay. So if I do 0.575 divided by 0.032, that's how many moles I have. So I have 17.97 moles. That's my N. Okay, now we can say PV equals nRT. So nRT over P is the V. What's the 4? It's on the calculator as well, isn't it? 27. And the temperature is 283. And then the pressure is 1.51 times 10 to the power of 5. So I got a volume of 0.28 meters cubed. Okay. What's the temperature that I say? 283. Now the next part you could actually use the same formula. Or you could use Boyle's law, but sure you can use the same formula again. What's the only difference in the second part here? Just change the pressure. So if I put in a different number for pressure, I get 0.168 meters cubed. You know, 6 marks for these two. And lastly, part 3, what is the density? So Louise definitely knows the density now.
Yes, hello.
Yep.
Density equals mv.
Mass over volume, isn't it? Yeah. Mass over volume. But they try to trick you a little bit here. It's very, very sneaky. The temperature is now different for the last part. What's the temperature? 0 Celsius. So in fact, do you use this number? No. Do you use this number? No. You have to calculate the volume again. But this time, the temperature and the pressure, they're both different. What did I say the N was? 1797. And then what did I say the R is? 8.31. The temperature is now 273, and the pressure is now 1.01 times 10 to the 5. So the volume will be 0.404 meters cubed. Okay, Louise, what's the formula for density?
Density equal M over V.
Yeah, and what's the M in this question? 0.575. Yeah, and the volume is 0.404. Mass is given. Yeah. Yeah, so as we were saying yesterday, it's about 1. It's a little more than 1. And in fact, that's the type of number you would expect, considering that water is 1,000 kilograms per meter cubed. It's quite small, actually.